All right, the infamous red and grey kangaroos problem. This problem has been around since I was in high school. So let's get stuck into it and try to flesh it out and really understand what's going on with it. Okay, so what we've got in this scenario is that there are approximately 10 times as many red kangaroos as grey kangaroos. Okay, so for every one grey kangaroo, there's 10 red kangaroos. If the population of grey kangaroos increases at a rate of 11% per annum, while that of the red kangaroos decrease at 5%, how long before the proportions are reversed? That is, that there's going to be 10 times as many grey kangaroos as red kangaroos. All right, well, here's how we do this problem. So the first thing to note is that we're going to write the growth function for each of the respective kangaroos. So the grey kangaroo growth function is going to be G0, the initial amount of kangaroos, multiplied by 1.11 to the power of n. All right, so that will take whatever the initial amount of grey kangaroos there are and multiply it by 11% or increase it by 11%. Now let's do the red kangaroos. Now what that's going to be is the initial population of red kangaroos multiplied by, in this case it's a decrease, so 0.95 to the power of n. All right, what we can do though is we know something about this R0 value. Okay, so initially, this is the situation at the moment, is that I know that actually R0 is 10 times that amount of G0. Okay, there's 10 times more red kangaroos as there are grey kangaroos. So what I can do is actually rewrite this function as 10 times G0 times 0.95n. So notice that what I've done is replace that with that. All right, now how to proceed from here? Well, what I want to have happen here is that at the end of this, I want the grey kangaroo population to be the same as 10 times the red kangaroo population. So what I'm going to do is set up these equations here like that. So I've got G0 times 1.11 to the power of n is the same as 10 lots of this equation here. 10 lots of 10 times G0 times 0.95 to the n. All right, so what that's going to be then is we're going to say that this is 100 times G0 times 0.95 to the n is G0 times 1.11 to the n. All right, now what's going to happen is I'm going to divide by G0 and G0, which knocks that out basically. All right, then what I'm going to do is, well, let's just rewrite it. 1.11 to the n equals 100 times 0.95 to the n. Now I'm going to take a log of both sides. And remember, when you log both sides, you can choose really any base that you want to choose. All right, so I'm going to choose base 10. I'm going to go log 10, 1.11 to the n is equal to log 10, 100 times 0.95 to the n. Let's chuck some brackets around that. All right, open, 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 close, close, close. All right, now notice that these two things have been multiplied together. So what I'm going to do is strip this back to n 1.11. So I'm just going to use that log law to drop that n as the coefficient. Then I'm going to write this as log 10 100 plus log 10 0.95 n. Okay, so I'm just going to pull those apart because they're being multiplied. When we multiply these things together, what I can do is split them or go back to a more unsimplified version of that. All right, now, why did I do that? Well, let's keep processing this. So this is n log 10 1.11. Take away, so I'm going to do two moves at once here. I'm going to rewrite this as n log 10 0.95 and subtract it at the same time. So it's n log 10 0.95 equals, now log 10 100 is just 2. All right, now let's factor out the n, and I've got log 10 1.11 take away log 10 0.95. equals 2. We're going to say that n is equal to 2 over log 10, 1.11, take away log 10, 0.95. So there's our exact answer, and I think if you plug that into the calculator, that n value from memory was 29 point something, which meant that it was going to be 30 years. Okay, so that's how to think through that problem there, but that's taken me a long time to get to that point there, and that problem has caused me to do plenty of thinking over the years.